If you're running an estate of Java microservices, chances are you have a setup similar to this. Load balancers serving one or more of your endpoints, and a pool of EC2 or Docker containers running your Java applications. You've also possibly been thinking about serverless architectures and how great it'd be to benefit from cost-efficient, elastically scaling functions with reduced infrastructure and attack surface. But how do you get to there from here in an iterative fashion that doesn't require an upfront wholesale rewrite? If you've been looking for options, chances are you've come across Spring Cloud Functions. This allows you to slice up your fat Spring Boot microservices into functions that can be deployed onto AWS, GCP, or Azure with minimal changes or configuration. But if you've been down this road, you've probably hit the cold boot time problem. Functions typically run on a small amount of memory and CPU, and constraining your average Spring Boot application into that can result in load times of over a minute. Although this only impacts users who hit your function cold, depending on your traffic profile, this could be a regular occurrence, and even one bad experience isn't great. It's taken this typical Spring Boot app turned function this long to start up, with 768 meg of memory, which is far too inefficient and cost prohibitive. But what if I told you this function uses exactly the same code base, runs on 256 meg of memory, and starts from cold in around 3 seconds? The difference is GraalVM. It allows us to compile Java applications ahead of time into native binaries that can then start up significantly faster than applications running in the JVM. It does this by packaging all of the required components of the JVM, such as garbage collection and thread management, alongside application and dependency code identified using static code analysis. This gives us the stepping stone to decompose Spring Boot microservices into functions and to begin adopting serverless architectures. From here, you can start to further decompose and modernize your architecture by tuning your functions to have the optimal resource allocation for the needs, choosing the right programming language and tooling for the job, separating out your data stores and adopting the likes of event-driven and CQRS patterns. It also empowers your cross-functional teams by being able to focus on horizontal slices of features and functionality and own them from end to end. This can reduce the dependencies between squads and improve agility. So where do you go from here? Well, with this stepping stone, you can start to experiment with a single endpoint or operation to begin with. Read my blog for implementation steps, work with engineers to build a proof of concept. Ensure you prepare your teams to operate and support serverless architectures if you don't already use them. And finally, give it a go. The time has come for Java to make an impact in the serverless world, and GraalVM with Spring Cloud Functions is a game-changing combination.